So in this goal, we are going to learn about interpreting solubility charts. So whenever you have a chart or a graph, it's a way to organize complex information so that you can look for patterns and trends. So let's look at this graph. So this is the same graph that's found in your packet, and I have it copied two places in your packet, so it'll be easy to use this graph. And all the questions from your packet do refer to the solubility curve here. So let's look at this solubility curve. So first of all, I want you to notice that right here on our y-axis, each of these lines is measuring how much solute per 100 grams of water. So 100 grams of water was taken, and each one of these chemicals was added to the 100 grams of water, and then put at different temperatures, and then they measured how much of the solute was able to be dissolved in that 100 grams of water. So notice that we have um, grams of solute over here starting from 0 all the way to 140, and then you can see that it even goes off the chart. So you could extrapolate that to figure out how much, for example, this potassium iodide would be able to be dissolved in, say, 40 degrees Celsius. Let's look at the bottom. On our x-axis, we have our temperature going from 0 degrees Celsius to 100. Why do you think it stops at 100, and why does it start at 0? Well, it's because water only exists as a liquid between those two temperatures. So less than 0 degrees Celsius, we're going to have solid ice. So you're not going to be able to dissolve anything. And above 100 degrees Celsius, we're going to have a water vapor. And again, you're not going to be able to dissolve anything into water vapor. So that is why we're limited with our temperature. So first of all, what is solubility? So solubility is how much solute will dissolve in a given solvent at a given temperature. So in this chart, we're talking about water as our solvent, and our solute are all these different chemicals here, from potassium iodide all the way to our sulfur dioxide down here. So when you first take a glance at this, notice that most of the chemicals, they are lower or they don't dissolve as much when the temperature is low, and that they dissolve more when the temperature is high. Well, those are your solid solutes. So again, the solubility goes up as the temperature increases. And there actually are some gases here. Gases actually do the opposite. As your solubility, as your temperature decreases, you actually can dissolve more gases. Can you find the gases here on the chart? So the gases on the chart, they go the opposite direction. So, and there are three of them. So one of them is this sulfur dioxide, the SO2. Another one is this ammonia, NH3. And where's the other one? Oh, right here, the hydrochloric acid, HCl. So you can see that as the temperature increases, then less and less can be dissolved. So that's one thing that you can look on your solubility curve chart, and you can look and see the difference between solids and gases, and you can find the solids and you can find the gases. All right, so now let's look at each one of these lines. So each line represents the maximum amount of solute that can be dissolved in that temperature of water. And so each solid line represents what we call a saturated solution. So when we think saturated solution, we think that all the spaces in between the water molecules are filled with that solute. So that water can hold no more of that solid powder or of the gas. Um, Maybe an analogy would be like a kitchen sponge. So that kitchen sponge is saturated when it is filled with liquid in all the little spaces of the kitchen sponge. So it's kind of the same way in a solution. So your water has a limited amount of spaces that a solid can fit in. And past that point, it just won't dissolve. It'll just be a solid at the bottom of the beaker. So each of these lines, again, represents a saturated solution, the maximum amount of solute that can dissolve in that 100 grams of your solvent. Now, if you are below the line, then this whole region represents an unsaturated solution. So let's take a look at one chemical. Let's go ahead and look at the sodium nitrate, the NaNO3. So it's this line right here. Oh, let me pick a different color. So again, the sodium nitrate right here. Let's look at this line. So we see that this is where it is saturated. And below that line, this whole area, because again, we're looking just the sodium nitrate, this is where it is unsaturated in this whole area. And obviously, if we're looking at a different chemical, then we'll look at a different line and under that line. So what unsaturated means is that I can dissolve more solute. So for example, let's say I am right here on the chart. So right here on the chart, I have about 80 grams of the sodium nitrate, and I find that it's not on the line. So because it's not on the line, it's not a saturated solution, it's an unsaturated solution. How much more sodium nitrate could you put into this solution at that point? Well, you could make a little measurement. So here is 80, and if I go all the way up to that saturated line, so that would be about 105, you would just take 105 minus 80 to figure out that you would need 25 more grams to make that unsaturated solution saturated. Now, we say a solute is very soluble if a lot of it can dissolve in water. And if only a minimal amount can be dissolved, we say it is not very soluble. So let's look at 10 degrees, which solute is the most soluble and which one is the least soluble. So for this, we're going to go to 10 degrees. So it's on my x-axis right here. And I'm going to just follow it up. And the first line that I come across is this one. And so this one is our potassium chlorate, our KClO3. So this is the one that is the least soluble. And it's the least soluble because it's the lowest on the curve. So, whoops, I didn't mean to write least. I meant to write potassium chlorate is our least soluble. Which is the most soluble? So we will look up and find the very top most line that crosses that 10 degrees, and we find that Ki, or that potassium iodide. So that one is the most soluble at that temperature. Here's a different graph just for fun. So go ahead and try to figure out at what temperature will 220 grams of sugar dissolve in that solute of 100 grams of water. And then also determine how much sodium nitrate will dissolve in 100 grams of water at 60 degrees Celsius. So stop the video and read the graph and try to figure it out, and then we'll come back and tell you the answer. Okay, we're back. So the first one says at what temperature were 220 grams of sugar. So the only value that they give us is the 220 grams. So we're going to start there. So we're going to look over here on our graph and find 220 grams of the sugar. So I'm going to look for the solute, and that's right here. And a clue here is, again, the temperature only goes from 0 to 100. So if I'm at 220 grams, of course, I'm going to be looking at my y-axis because only the y-axis goes up to 220. So I'm just going to read across 220 until I come to that sugar line, which is right there. So right where it crosses that line, that is the temperature at which 220 grams is dissolved. And so you can just kind of eye that. And I think it's right about in between the 20 and the 40. So I'm going to say 30 degrees. 30 degrees Celsius. So 30 degrees Celsius, and my sig figs are good because I know it's in between the 2 and the 4. So I really only have one significant figure. So just 30 degrees Celsius would be my answer. Let's do the second one. How much sodium nitrate will dissolve in 100 grams of water at 60 degrees Celsius? So I already know that this whole chart is set up for 100 grams of water. So really the value I'm going to be looking for on this chart is that 60 degrees. So I find the 60 degrees Celsius, and I'm going to follow that line up until I can find NaNO3. So going up, I see my NaNO3 is right there. So I'm going to look at this line right here, okay? So following the line up here, boy, there's like 3 lines there. So it's the top one that we're looking at. So when we go across here, we're just kind of guesstimating what it is. So reading the value that we have. So we see that it's between 100 and 140, and we're just going to kind of guess what's there. So I'm going to say it's 130. And you might think it's a little bit different, maybe 125, but I think it's around 130. So um, oh, and I did my unit wrong. So it's not 130 degrees Celsius, it's 130 grams. Okay. If you read the question again, you can check that. How much of the NaO3 will dissolve? So it's 130 grams will dissolve. So you need to be able to read these charts given the temperature, figuring out how many grams will dissolve, or if you're given how many grams will dissolve, read the temperature. And so you just read where that solubility curve or that line, that saturated solution line, that's where what you're trying to line up. Okay, so let's look at this one. So 40 grams of KNO3 is dissolved in 100 grams of water at 40 degrees Celsius. So we're asked these 2 questions. Is the solution saturated? And if it is unsaturated, how much more material can be dissolved? Um, and then we also have this question. If the temperature drops to 20 degrees Celsius, what will you see in the solution? So I'm going to have you do the first 2 questions, the questions in yellow. And then, so go ahead and stop the video and try to figure that out. And then we'll come back and we'll work through the last question. Okay, we're back. So working on these questions in yellow. So we first need to find the 40 grams and the 40 degrees Celsius. So that was really nice. So we don't have to be worrying about what is the x-axis and what is the y-axis because they're both 40. So we have 40 degrees Celsius is here, and then we have 40 grams is here. So right where those intersect, and we're going to look at the KNO3. So the KNO3, I'll draw it in green here, is the curve that comes through right here. All right, so that's what we're looking at for 40 degrees and 40 grams. All right, so 40 degrees and 40 grams, I am right smack dab on my graph right there, okay? So the first question, is the solution saturated? So it's only saturated if it's on the line, and it's not on the line, it's under the line, so it is unsaturated. So it is not saturated, so no, okay? If it is unsaturated, and that is what we have, how much more material can be dissolved? So we are at 40 grams, and we're just going to figure out how many grams dissolve right at that 40 line. So it's right in between the 60 and the 70, approximate, maybe a little bit more right in between, about 65 grams when it would be saturated. So we're at the 40 gram mark. So I just go 65 grams minus 40, and I get my 25 more grams is what can be dissolved. All right, so let's go back to our 40 grams and our 40 degrees. So we're right here. I'll draw it in an orange X. And let's look at this question. It says, if the temperature drops to 20 degrees Celsius, what will you see in the solution? So right here underneath the curve, it's unsaturated. I could add 25 more grams to make it a saturated solution, but I'm not going to do that. Let's go ahead and do this question. It says, if the temperature drops to 20 degrees Celsius, what will you see in the solution? So let's go and follow it across. So the temperature is dropping, the temperature is dropping. Right here, it's saturated. And if I keep going to this portion right here, this point, what we will see is we see that we crossed that saturated solution line. And so that we see, because we passed the saturated solution line, we'll actually see this drop out of solution. And what dropping out of solution means is that powder, or excuse me, a solid will actually appear in the solution. So it kind of looks like a cloud in the solution. And that's because the water at this temperature, it can't hold that 40 grams of the solute. So you will see once you pass uh, above that saturated solution line, you will see solid appear. And given time, it will sink to the bottom of your beaker and, and it will not dissolve at that temperature. So that's what happens if you cross over the saturated solution line. All right, so this is table practice. Go ahead and stop the video and work through each of these problems, and then turn the video back on and I'll go over the answers. Okay, we're back. So let's look at question number 1. So looking at KCl, so I'm going to draw it right here in orange so we can see a little bit. It says how much solute can be dissolved at 60 degrees Celsius. So you're going to find 60 degrees Celsius and you're going to read it up, and right where it touches the line, that is the amount that can be dissolved at 60 degrees Celsius. So I find it's right in between the 40 and the 50, so I'm going to say 45 grams. So, and you might think it's a little bit more, a little bit less, but as long as you're close, it's fine. All right, this solution would be saturated or unsaturated. So because it's asking how much solute can be dissolved, that would be a saturated solution because we're going up to the line. Remember, the line is a saturated solution. Let's go ahead and do question number 3. Now, question number 3 says, if 50 grams of KCl is dissolved in 90 degrees, would this be saturated or unsaturated? Or saturated or unsaturated? I think I still said the same thing. But let's look and find KCl. So KCl, oh, it's the same one. So we're still looking at that orange line. This time we're looking at 50 grams at 90 degrees Celsius. So 90 degrees Celsius and 50 grams. So we find that we're right here. Okay, so that's the 50 grams at 9 degrees Celsius. So where are we now? So still looking at that orange curve. So we find that we're below the line, so this would be an unsaturated solution. Okay, and now it says if the above solution is cooled to 50 degrees Celsius, what would you see? So again, we're going to cool it down to 50. So we're just going to cool it off. So right on the line, it would be saturated. But then as I keep cooling it, when I get to 50 to right here, you would see that once you get past or above that saturated line, you would see it drop out of solution. Or in other words, the solute would appear. And like I said before, it kind of looks like a cloud, like in the solution, but then over time it would sink to the bottom of your container. All right, number 5, why does the temperature only go from 0 to 100 degrees Celsius? And because that is the temperature that we find water is a liquid.